Hi everyone, welcome back to channel. Today's topic is water bath. We'll cover what it is, how it works, its parts, the different types, and, most importantly, why it's such a valuable tool in the pharma industry. Let's get started. What is a water bath? In simple terms, a water bath is laboratory equipment used to maintain a sample at a constant temperature for a specified period. It's essentially a container filled with water, with an adjustable heating element that ensures the water and anything immersed in it stays at a precise temperature. Principle of the water bath. The key function of a water bath is to keep samples at a steady temperature, which is vital for many chemical and biological reactions. The water bath works on the principle of heat transfer, where heat is uniformly transferred from the heating element to the water. This water, in turn, transfers heat consistently to the samples. The temperature is controlled by a thermostat or digital controller, which prevents fluctuations, ensuring accurate results. Parts of a water bath. Understanding these parts will give us insight into how it works and how to maintain it. Tank. The tank holds the water and samples. It's usually made of stainless steel to prevent corrosion and make cleaning easier. Heating element. The heating element, usually located at the bottom of the tank, is what warms up the water to the set temperature. Temperature controller, either a thermostat or digital control panel. This component allows the user to set a specific temperature and maintain it. Lid or cover. Most water baths come with a lid or floating covers to minimize evaporation, especially at higher temperatures. Indicator lights. Many water baths have indicator lights that show when the water is heating, as well as when the desired temperature has been reached. Types of water baths. There are various types of water baths, each suited to different types of laboratory work. Here's a look at the most common types used in pharmaceutical labs. Non-circulating water bath. This is a basic water bath with no water circulation. It's generally used for tasks that don't require precise temperature uniformity. Circulating water bath. Equipped with a pump to circulate the water, this type ensures even temperature distribution. It's ideal for experiments needing highly consistent temperatures. Shaking water bath. This water bath includes a shaking mechanism, which keeps samples moving continuously. It's perfect for tasks like mixing or dissolving substances in a solvent. Refrigerated water bath. When samples need to be kept cool, a refrigerated water bath is used. This type is common in biochemical labs for enzyme and protein studies. Digital and programmable water baths. Advanced models that allow users to set temperature cycles, ideal for regulated pharma tests where precise conditions must be maintained over time. Procedure for operating a water bath. Operating a water bath is straightforward, but following a precise procedure ensures accuracy and safety. Here's a step-by-step guide. Fill the tank with distilled water. Always use distilled water to prevent mineral buildup, which can affect heating efficiency. Set the temperature. Use the thermostat or digital control panel to set the desired temperature. Let the water reach this temperature before placing samples in it to ensure stability. Place samples in the bath. Put your samples in suitable containers, and ensure they are properly secured. Avoid placing too many samples to ensure water can circulate around each one evenly. Use a lid or floating cover. Minimize water evaporation by using a lid or floating covers if available. Monitor the temperature. Although modern water baths are precise, it's good practice to monitor the temperature with an independent thermometer, especially for sensitive tests. Uses of water baths in pharma. Water baths are highly versatile and support many essential applications in pharmaceutical research and development. Here are some key uses. Solubility testing. Water baths help determine the solubility of drugs, which is critical for formulation studies. Dissolution testing. This involves testing how fast a drug dissolves in the body, a critical factor in its effectiveness. A water bath ensures precise temperature control for this test. Incubating bacterial cultures. A steady, warm environment is ideal for growing bacterial cultures used in antibiotic development, enzyme and chemical reactions. Many enzymes need precise temperatures to function, making water baths perfect for enzyme assays. Sample preparation for analysis. Sometimes, samples need to be warmed or dissolved at a specific temperature before analysis. Water baths are ideal for these types of preparatory steps. Tips for maintenance and safety. Lastly, let's look at some important maintenance and safety tips to keep your water bath in top condition. Regular cleaning. Clean the tank at least weekly to prevent microbial buildup. Avoid abrasive cleaners that could damage the tank. Check water levels frequently. Make sure the water always covers the heating element, as running it dry can cause damage. Use algaecide as needed. If you're using the water bath for extended periods, adding an algaecide can prevent algae growth. Unplug when not in use. This prevents overheating and potential electrical hazards. Wear protective gear. Always use gloves and goggles when handling hot samples to avoid burns or splashes. Following these tips can help prolong the life of the water bath and keep your lab a safe environment. And that's everything you need to know about water baths in the pharmaceutical industry, from how they work to their applications and maintenance. Water baths may seem simple, but they're crucial in achieving consistent, reliable results in many types of research. If you found this video helpful, don't forget to give it a thumbs up, subscribe, and hit the bell icon so you never miss an update. Thanks for watching, and see you next time.